Exercise 8.2, we continue with question number 9. You are given this expression 1 plus a raised to m plus n, and you want to show that coefficient of a raised to m and a raised to n are equal. Okay, so I'll just expand by binomial theorem. By binomial theorem, let's expand this. You know expansion here. M plus n c0 into 1 here, m plus n c1 into a, you know this, m plus n c2 into a square, one more if I write m plus n c3 into a cube. I want coefficient of a raised to m. So if I have a raised to m here, then it must be m plus n c m here. If I continue, if I write m plus n c n here, then it must be a raised to n, and so on till the last term. Now you want the coefficient of a raised to m, which is this, and coefficient of a raised to n, which is this. By observation also you can write coefficient of a raised to 1 is this. If you have a square, then here you have 2. If you have a cube, you have 3 here. So therefore, if I write here coefficient of a raised to m equals to m plus n cm. Use that NCR formula. So m plus n factorial upon this minus this, which is n factorial into m factorial. Call this as 1. Okay. And one more here, coefficient of a raised to n, that is equals to this one, m plus n cn equals to m plus n factorial upon this minus this, which is n will get cancelled, so m factorial into n factorial. So from 1 and 2 you can see that these two are equal. So clearly from 1 and 2, coefficient of a raised to m equals to coefficient of a raised to n. These two are equal, right? And therefore proved. That's what the first question here. Question number 9 here. Fine. Now next question. Let's see the question number 10. 10th question. 10th question. What's given? The coefficient of r minus 1th term, rth term and r plus 1th term in this expansion. You are given 1 plus x the whole raised to n. You are given this. Okay, are in this ratio 1:3:5, and you want to get n and r. So first we want tr minus 1 term, then tr term, and then tr plus 1 terms, right? These 3 terms you have. Now you just recall what is the formula for tr plus 1. It is NCR into, you know, a raised to n minus r into b raised to r. That you know. Fine, you know it. What is a here? 1. What is b here? X. Right? Here a is 1 and b is x. Right. So I'll write now t r minus 1 term. So it is n is there, nc 1 less, remember. R is 1 less than r plus 1. So here 1 less. So you have r minus 1 minus 1, that is r minus 2. A is 1 here. And what is b? That is x raised to this power. What is that? That is nothing but the r minus 2 power. Then tr, that is nc 1 less, r minus 1. A is 1 here, remember. What's a1? B is x. So x raised to the same power r minus 1. And tr plus 1. What is that? N, C, R, 1 less. A is 1, B is X. So X raised to R. Now these are the three coefficients. This and this. Coefficient means what? Constant terms with variable X. Okay. Now what's given to us? We are given this. We are given that NCR minus 2 is 2. That's the first coefficient. NCR minus 1 is 2. NCR equals to, what's given to us? Equals to 1:3:5. This is given to us. I have just written the coefficients here, remember. Right? This is the coefficient of TR R minus 1th term. This is coefficient of rth term, and there is a coefficient of which term? R plus 1th term. So we are given that these three coefficients are in this ratio. Now what we do? We use just elimination method. How? First we use this 2 ratio. So we'll get one equation in N and R. Then we use this 2 ratio. So we'll get one more equation in N and R, and we solve them. That's all in all. So let me use first 2 ratios here. So I'll get here NCR minus 2 upon NCR minus 1 equals to 1/3. One more parallelly here if I write NCR minus 1 upon NCR equals to 3/5. Fine, is it? One more time, what I did, this upon this equals to this upon this. This upon this equals to 3/5. That's what I did. Now we just simplify. We use formula you know. So I'll take this one over here into, what's the formula for this? N factorial upon this minus this, that is n minus r, and this will be plus, remember, plus 2 factorial into r minus 2 factorial equals to 1 into this. So here n factorial upon this minus this, so n minus r, and this will be plus factorial into r minus 1 factorial. What I did, I did 2 things here. First, cross multiplication, 3 into this, and then formula for this, you know very well. 1 into this, and then formula for this, NCR formula. What's the NCR formula? N factorial upon n minus r factorial into r factorial. Now what we do, this will get cancelled, obviously. This will get cancelled. And here we'll see every bigger factorial you can express in form of which factorial? Smaller factorial. So I'll do that. Now this is bigger, so I can write in form of this. So I'll keep 3 as it is here. N minus r plus 2. Do 1 less. So I'll get n minus r plus 1. Now I got this. I'll stop and write the factorial. Now out of these 2, which is bigger? This is bigger. R minus 1 factorial, you can write r minus 1 into r minus 2 factorial. So I'll keep this one as it is. I'll not change this, remember. This already cancelled, so here you have 1. This will get cancelled with this one. So right now this is as it is. R minus 1, 1 less. So I'll get the r minus 2 factorial. Ab jante, if you have 4 factorial, you can write 4 into a kam kar do, which is 3 factorial. Right? You know it. We did it very beginning of permutation and combination. Now what will see? See, this will get cancelled with this. This will get cancelled with this. So you are left with 3 upon n minus r plus 2 equals to 1 upon r minus 1. This one and this one. Do the cross multiplication. 3r minus 3 equals to n minus r plus 2. So what we'll get from this? Take r over here. So 4r. I'll take n over here, minus n, 3 over there, that's 5. So this is equation number 1. Call this as 1. This is one equation in R and N. R over here, so 4R. This N on the left hand side, minus N. I'll take 3 over there, so 3 plus 2, which is 5. This is one equation. Again we start with this now. So again now same procedure. We start with the other ratio. We start with the other ratio. Okay. So which ratio? This one. So I'll do directly cross multiplication. 5 into this. 5 into n factorial upon this minus this. N minus r plus 1 factorial into r minus 1 factorial. You know the formula. 5 into this n factorial upon n minus r plus 1 factorial into r minus 1 factorial. 3 is multiplied with this. So 3 into 5 factorial upon 3 into this one. Sorry, not 5 factorial, n factorial. N factorial upon n minus r factorial into r factorial. This is multiplied with 3. Okay, now question is simplification. This n factorial will get cancelled. This bigger you can express in this bigger you can express in this. So 5 as it is here, n minus r plus 1, do 1 less, that is here n minus r 1 less, so factorial. This one we keep as it is here. Here 3 into here 3 upon this one as it is. What about r factorial? 1 less, r into r minus 1 factorial. Okay, so this will get cancelled with this. This will get cancelled with this one. So what we are getting? 5 upon n minus r plus 1 equals to 3 upon r. Just simplify. So we'll get here 5r equals to here n into this. So 3n minus 3r plus 3. Okay, so if I rewrite here, let me rewrite this. So this is 8r minus 3n equals to 3. This is equation number 2. 8r minus 3n equals to 3. Now what we do? We solve these two equations. Which two equations? Equations 1 and 2. So let me write solving equations 1 and 2. I know this little bit lengthy but not difficult to remember. Okay, so we just solve these two equations. So equation 1 is multiplied with 2, so we'll get the 8r minus 2n equals to 10. And second equation as it is here, 8r minus 3n equals to 3. Just change the sign, minus plus minus. So this will get cancelled. This is here n and here you have 7. So n equals to 7. Put n equals to 7 in any one of those two equations. So let me write by 1. If I put n equals to 7 there, you will get the r equals to 3. So these are the values. Fine. Question number 11. You are asked to prove that in the expansion of this 1 plus x the whole raised to 2n, prove that, what is asked? Coefficient of x raised to n is twice the coefficient of x raised to n in this expression 1 plus x the whole raised to 2n minus 1, right? So here for this expansion, if I just expand, you will realize this is 2nc0 into 1, you know here, 2nc1 into x raised to 1, 2nc2 into x squared, and so on. So immediately you can say from this, the coefficient of x raised to n here is obviously, if you're square then here 2, if you're 1 then here 1, so obviously it is 2n cn. You can write dot dot if you want here, 2n cn into x raised to n, and so on. It will continue, remember. So coefficient of x raised to n is this much, 2n cn. Call this as 1. Okay. Now the other expression, and for the other expression, which one other expression? 1 plus x the whole raised to 2n minus 1. Now let's expand this. 2n minus 1 say 0 into 1, you know this. 2n minus 1 c1 into x raised to 1. Then 2n minus 1 c2 into x square, and so on. You want the coefficient of x raised to n, remember. Okay, so coefficient of x raised to n would be what here? You can just write, what will be that? If you are square then here 2, then 2n minus 1 cn. Now you need to show that this is same as this. That's what you need to, you want to show that this is equals to twice this. That's what you need to prove. Okay, fine. I hope this is clear to you. Coefficient of x raised to n is this. Coefficient means constant term with x raised to n. If you are square then here you have 2. So if you are raised to n, it must be n here. And in this, if you are square then it is 2. So coefficient must be here 2n minus 1 cn. So now we use 1 and 2 and we try to get that. So from 1 we have 2n cn. What is that? That is 2n factorial upon this minus this, which is n factorial into n factorial. Call this as, for example, big one. And from 2 you have 2n minus 1 cn, which is equals to 2n minus 1 factorial upon this minus this minus this. So you can just check, you will get here n minus 1 factorial into n factorial. Fine. Now just observe this. I want denominators equal here. So if I want n factorial here, what I'll do? I'll multiply and divide with n. So here n upon n into n minus 1 factorial, multiplying and dividing by n. Now can you tell me what is this? You know, this is n factorial, remember. This is n factorial. It's like 3 into 4 factorial. What is 3 into 4 factorial? Tell me. What is 3 into 2 factorial? It is 3 factorial. What is 4 into 3 factorial? It would be 4 factorial. This one, you know. So n into n minus 1 factorial is n factorial into n factorial as it is. Now here if I keep here 2 over here, if I multiply with 2 here, then I need to put 1 by 2 in front of this. So what will get here? 1 by 2 into, now what is this? This is 2n into 2n minus 1 factorial. So what is this? This is 2n factorial. Right? It's again the same concept, remember here. 4 into 1 less factorial, that is 3 factorial. What is that? 4 factorial, you know this. Right. So multiply dividing by 2. So we are getting this 2n minus 1 cn equals to this. So call this as big 2. So therefore, what you have proved from this? So from 1 and 2, you have coefficient of x raised to n equals to twice. So this 2 will get cancelled. Coefficient of x raised to n in this expansion. Which expansion? 1 plus x the whole raised to 2n minus 1. Here coefficient of, in which expansion? 1 plus x whole raised to n. It's proved. Right? You multiply this by 2, you will get exactly 1, you can see. multiply this by 2, you will get exactly this. The 12th question, you are given this expression 1 plus x the whole raised to m and coefficient of x squared equals to 6, that's given to you. And the question is find the value of m, that's the question. Okay, so here let's start with 1 plus x the whole raised to m. I'll just write 3 terms. So here mc0 plus mc1 into x plus mc2 into x squared and so on. If you want last term, mcm into x raised to m. You want the coefficient of x squared. What's the coefficient of x squared? It is this, right? So here I'll write coefficient of x squared equals to mc2, which is equals to 6. Now what is this? M factorial upon m minus 2 factorial into 2 factorial equals to 6. We are just simplifying this. So we'll get the m into m minus 1 into m minus 2. That will can cancel with this. 2 factorial is just 2. I'll take on the other side. So this is 12. Now one way is you can just expand this and you can make the quadratic equation, or the another way you can write directly like this. 12 you can write as a difference of the one number with product. I can write 4 into 3. So you can say that m must be 4. M equals to 4, right? And m minus 1 has to be 3. Then again m equals to 4. Okay. So let's continue with miscellaneous exercise now. Your first question is, you are asked to find these 3 unknowns, to find a, b and n. That's a question. And in the expansion of a plus b the whole raised to n, you are given first 3 terms. So let's write at least first 3 terms here. nc0 into a raised to n, nc1 into a raised to n minus 1 into b, plus nc2 into a raised to n minus 2 into b squared, and so on till last. If you want, you can write. You are given the first 3 terms. You are given this, this and this, remember. So therefore we have 729. nc0 into a raised to n equals to 729. What is this? Here nc1 into a raised to n minus 1 into b equals to how much? 7290. And one more, if I write here, nc2 a raised to n minus 2 into b squared equals to 30375. This is given to you. Fine. This much we are given here. Okay, now we need to simplify. These are the 3 equations and 3 unknowns. What is nc0? You know it is 1. So a raised to n equals to 729. Call this as 1. Just equation number 1. Okay. What is nc1? It is n. A raised to n minus 1 right now as it is, b as it is. That is 7290. Call this as equation number 2. What is nc2? If you just recall, it is n into n minus 1 into n minus 2 factorial. That will get cancelled with denominator upon 2 factorial. It's just 2. Into a raised to n minus 2 into b squared equals to, you have 30375. This is equation number 3. So now we have these 3 equations, remember. We try to solve these 3 equations. So here 2 I can write like this, n into a raised to n, a raised to minus 1, which I'll write upon a, into b equals to 7290. But I know a raised to n. What is a raised to n? This is from 2, remember 2 implies we have this. What is a raised to n? 729. So n into b by a, here 729 equals to 7290. So you are just left with here nb by a equals to 10. Call this as just 4. Right? Okay. What about this? Here equation number 3 I can write n into n minus 1 by 2. These I can write as a raised to n by a square, b square as it is, equals to 30375. That you know. Okay. A raised to n again you know. So let me keep n into n minus 1 by 2 as it is. What is a raised to n? That is, you know, 729 into b square as it is, a square as it is, equals to 30375. Now you just divide. So here if you divide by that, you will get this into b square by a square equals to 30375 divided by 729. Fine. Now here b square by a square you can put from equation number 4. This much you can just put from which equation? Equation number 4. So we'll get n into n minus 1 by 2. What is b square by a square? B square by a square, that is 10 square, which is 100 obviously, by n square, equals to, we have 30375 upon 729. I hope this is clear to you. What I did, I've just placed the value of b by a here, which is b square by a square gives us 10 square by n square. Fine. Now further here, if I simplify, what I'll get if I simplify? 1 n will get cancelled. So you have here n minus 1 upon n into, this is 100 by 2 equals to 30375 by 729. So now just we simplify. Okay, so here n minus 1 by n, this is just 50, which I'll take down here, 30375 upon 729 into 5050. So here n minus 1 by n, at least by 5 you can divide this. So you'll get the 6075, and here you will get the 10 dividing by 5. So this is 7290. 2 cross multiplication. So 7290 into n minus 7290 equals to 6075 into n. So let's simplify. If I take this one on the other side, 1215n equals to 7290. So from these you'll get the n equals to 6. Fine. Now go to equation number 1. So equation 1 we have a raised to n equals to 729. So a raised to 6 equals to 729. Now 729, you know, it can be written as, very easily you can see this, 3 raised to 6, and therefore a must be 3. Fine. Now you have a, you have n, so you can put into equation number 2. So by 2 again, what's equation number 2? N. What's n here? 6. What is a? 3. So 3 raised to 5 into b equals to 7290. So b equals to 7290 upon 3 raised to 5 into 6. and here if you simplify, so here this is 3 raised to 6 into 2. Now this is 729, so we'll get 10 by 2, so we'll get just 5. So these are the values of three unknowns, N, A and B. It's a little bit lengthy because of that multiplication operation, but not difficult. You can try yourselves by some another way also. It's just you need to use the concept of the ratio, remember. So in the next question, you are given this expression 3 plus ax the whole raised to 9. You want the coefficient of x squared and x cubed. So I'll just expand it. 3c0, 9c0, 3 raised to 9, 9c1 into 3 raised to 8 into ax the whole raised to 1, 9c2 into 3 raised to 7, a into x the whole square, plus what we'll get here, 9c2, 9c3, 3 raised to 6 into ax the whole cube, and so on. Now we stop, no need to do further because we want the coefficient of x squared. So coefficient of x squared and coefficient of x cube. Coefficient of x squared is equals to coefficient of x cube. This is what we are given. Okay, now what's the coefficient of x squared? One is 9c2, 3 raised to 7 and a squared, remember. Constant term with x squared. So a squared 3 raised to 7, 9c2 equals to, what about the other side? 9c3, here 9c3, then 3 raised to 6 and a cube. Constant with the x cube, that is a cube, 3 raised to 6 and 9c3. Fine. Now we just simplify. So we'll get the value of a squared and a cube. So you're just left with a. 3 raised to 7, 3 raised to 6. So here we are left with 3. What is 9c2? 9 factorial upon 7 factorial into 2 factorial. What is 9c3? 9 factorial upon 9 minus 3, which is 6 factorial into 3 factorial. 9 factorial will get cancelled. Here, if you want 3 factorial, 6 factorial into 3 factorial into 3 is already there, upon 7 factorial into 2 factorial equals to a. You want a, remember, that's a question. 7 factorial you can write as 7 into 6 factorial. So this will get cancelled. Fine. 3 factorial, that is 6. 6 3s are here 18 upon here you have 7 into 2 equals to a. So what's the value of a? 9 by 7. That's value of a here. Third question. Find the coefficient of x raised to 5. To find, what you want to find? To get the coefficient of x raised to 5. Where? In the expansion of this product, remember, 1 plus 2x the whole raised to 6 into 1 minus x the whole raised to 7. So using binomial theorem, what I'll do, I'll expand this first, then this, and then we observe where we'll get x raised to 5. So I'm expanding this. 6c0 into 1, 6c1 into 2x, you know, raised to 1, plus 6c2 into 2x the whole square, plus 6c3 into 2x the whole cube, plus here let me write 6c4 into 2x the whole raised to 4, 6c5 into 2x the whole raised to 5, 6c6 into 2x the whole raised to 6. This is the first bracket. Into I have the other expression. Let me write into, in the product it is going, remember here, into the other one, that is this one. What is that? There we will have 8 terms because you raised to 7. So 7c0 here into 1 plus 7c1 into x raised to 1. So you have minus sign, remember here, minus x. Minus sign is there. Plus here 7c2 into minus x the whole square. 7c3 into minus x the whole cube. Minus sign is there, remember. 7c4 into minus x whole raised to 4. This is positive. 7c5 minus whole raised to 5. So here minus will come. 7c6 minus x raised to 6. And last term, which is 7c7 into minus x raised to here 7. So this is also minus outside. Fine. Now in the first bracket you have total 7 terms because raised to 6. Here you have 8 terms. So 7 into 8. So total you have, if you open this with this, then this with each of this with each of this. So total there will be, 7 into 8. That is 56 terms. In all these terms, where is x raised to 5 that you need to see. So I'm writing directly here. You will see how I'm doing. Coefficient of x raised to 5. In the product where you are getting x raised to 5, that you need to see. So here now we just multiply. You can see that 6c0, this first term, you can multiply with each of this. So where you will get x raised to 5 here. 6c0 with this. So 6c0 into, here minus sign is there, remember, into 7c5 with minus 1. This minus 1 will come as a coefficient of x raised to 5. This into this. Plus, now, here you have x, remember. So that x is multiplied with which one? You will get x raised to 5 with x raised to 4. What's the coefficient of x here? That is 6c1 into 2 into this x raised to 1 is multiplied with x raised to 4, but this is because of even power, this will be plus. So into 7c4. 6c1 into 7c4. X raised to 4, x raised to 1, x raised to 5. Then come to x square. Here 2 square is there, remember. So plus here 6c2 into 2 square. This 2 square, and that x square is multiplied with which one? X cube with minus sign. So 7c3 into minus 1. I repeat, this x square is multiplied with which one here? X cube. So x cube into x square gives us x raised to 5. Here minus 1, 7c3, 6c2 and 2 square. Plus, now next here cube. So there you have 6c3 into 2 raised to 3, which is 8 into, now x cube is multiplied with what here? X square, remember. But this will be plus, so into 7c2. 7c2, this is x square, this is x cube, 2 raised to 3, which is here 8, and 6c3. Plus, let me write one more here. X raised to 4, that's 2 raised to 4 is there. So 6c4 into 2 raised to 4 into x raised to 4. That x raised to 4 is multiplied with this, remember. Here minus sign is there. So into 7c1 into minus 1 into minus 1 here. X and x raised to 4 gives us x raised to 5 plus, now here you have x raised to 5 that is multiplied with this constant term. So we'll get a x raised to 5. So 6c3 into 2 raised to 5 x raised to 5 with this constant term into 7c0. So you need to simplify all, not a big task. It's a good practice for you for NCR symbol, like 6 is 0 is 1, 7 say 5 and so on, simplify. So you will get finally that Beck's said answer. Check. This is what the procedure. I hope what I'm trying to tell you is clear to you. With this, you multiply each of this. So where you will get x raised to 5 here. So 6 is 0 into 7c5 into minus 1. Here you have x raised to 1. Now this is multiplied with each of this. So where you will get x raised to 5 if it is multiplied with x raised to 4, because x raised to 1 is there. So 6c1 into 2 into here you have 7c4 into, this is 1, remember, because minus 1 raised to 4 is just 1. Then next come to x squared term, 2 square 6a2, that should be multiplied with x cube. But here minus sign will come into 7c3 and so on. X raised to 5 is multiplied with constant term. So that's the final term here. If x raised to 6 is multiplied with any one of these, always you will get x raised to 6 or the more power. So no need to consider this. Now question is, you simplify this, here your minus sign, remember. Here also your minus. Simplify, so you'll get the Beck's answer.